Assalamualaikum and hi everyone. Today we are going to learn about probability. For your information, probability is one of the most important topic in mathematics management semester 2. In this video, we will cover two learning outcomes. By the end of this video, students should be able to determine whether two events are mutually exclusive and determine whether two events are independent. Okay, now let's look at what is the definition of mutually exclusive events. Two or more events are mutually exclusive or disjoint if the events cannot happen at the same time when the experiment is performed. Mutually exclusive events can be shown by using the Venn diagram as follows. As you can see that there are two events in the Venn diagram stated that event A and event B. If A and B are two mutually exclusive events, then the set of A intersection B is an empty set. And B, the probability of A intersection B must be equal to 0. And C, the probability of A union B equal to the probability of A times the probability of B. Okay, now let's look at the independent events. If events A and B are independent, then the probability of A given that B equal to probability of A, or equivalently the probability of B given that A equal to probability of B. And the second one is the probability of A intersection B equal to probability of A times probability of B. Now we look at the Venn diagram below. The probability of two events stated that the probability of A union B equals to the probability of A plus probability of B minus the probability of A intersection B. This formula you must remember because this is the most important formula that you can use to solve the problem regarding the independent events problem. Okay everyone, let's look example 1. Given that PA equal to 0.8, PB equal to 0.4 and PA union B equal to 0.9. Determine if A and B are mutually exclusive events and if A and B are independent events. Now we look at the solution. The question A is about mutually exclusive events. As I mentioned in the previous slide, the formula of the mutually exclusive events stated that the probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So, based on the formula, we must find the probability of A intersection B. So, you can just substitute the value in the formula. So we can get that 0.A plus 0.4 minus 0.9, that the probability of A intersection B is equal to 0.3. Since the probability of A intersection B not equal to 0, therefore A and B are not mutually exclusive. Okay, now we move to the question B. And the question B needs you to find the independent events of A and B. If A and B are independent, then the probability of A intersection B must equal to probability of A times probability of B. So, based on the answer in A, you just substitute the value of 0.3 in the probability of A intersection B, and on the right side, you must times probability of A and probability of B. So, the answer is the left side is 0.3 and the right side is 0.32, meaning that the left side and the right side is not equal. So, A and B are not independent events. Okay, now let's look at example 2. A card is drawn randomly from a standard deck of 52 cards with replacement. Determine whether the events getting a spade and getting a numeric card are independent. First of all, when you see question like this, you must mention what is the event A and event B. So, in this question, the event A can be stated as getting a spade and event B getting a numeric card. With replacement doesn't matter here since only one card is drawn. So, standard deck has 52 cards. There are 13 spades, so the probability of A equal to 13 over 52, and simplify the answer, you can get 1 over 4. And the numeric card usually started from 2 through 10, so there are 9 cards. Each rank has 4 suits, so there are 9 times 4 that equal to 36 numeric cards. So the probability of B is 36 over 52, and simplify we can get 9 over 15. And the next step is find the joint probability of P at intersection B. Numeric spade, the spade card from 2 to 10, there are 9 cards. So, the probability of P at intersection B equals to 9 over 52. If A and B are independent, then the probability of A and B must equal to probability of A times the probability of B. So, we can get that the probability of A intersection B is 9 over 52, and the probability of PA times probability of B equal to 9 over 52. Based on the previous slide on the independent events, you must remember that to find the two events are independent, the right hand side and the left hand side must be equal. So, as you can see that the probability of A intersection B equal to the probability of A times the probability of B, meaning that the events getting a spade and the getting a numeric are independent. Now let's look at the last example. The table below shows 80 students registered for a programming course. Determine whether the events a girl is selected and a student registered advanced programming is selected are independent. First of all, you must state what is the event A and event B. Let event A be a girl is selected and event B be a student registered advanced programming is selected. From the table, we can find the probability of A first. Probability of A is equal to 11 plus 24 over 80. 11 plus 24 is regarding the girls who take a basic and advanced programming course over the sample size that is 80. So we calculate that we find 35 over 80 and simplify the answer, we can get 7 over 16. And next, we must find the probability of A given that B using the conditional probability formula. So, conditional probability formula stated that the probability of A given that B equal to the probability of A intersection B over probability of B. So, we just substitute the value from the table into the formula, and we can get that 24 over 53. Since the probability of A given B not equal to the probability of A, therefore, the two events are not independent. Okay everyone, I hope this video will help you to understand and enhance your level of understanding about mutually exclusive events and independent events. Thank you for watching and bye.